This is your continuation of exemplars. We've done videos on Law 1, 2, and 3, and today we're going to focus on Laws 4 and Laws 5. So we'll start here with Law 4. And Law 4 states the product of two numbers, two or more numbers, to an exponent the product of two or more numbers to an exponent can be rewritten with each of the numbers in the product given the exponent. Now that sounds complicated, given the exponent. The product of two or more numbers to an exponent can be rewritten with each of the numbers in the product given the exponent. That's about as wordy as you can possibly get. But if we look at the exemplar, we have this. There's the product of two numbers to an exponent of 2. Now this works with the product of two numbers, not the sum or the difference of two numbers, only the product of two numbers. It does not work if you're adding them. So this won't work. And we can look at that after to show why it won't work. We'll show this how this works. So what this means is it can be rewritten as the first number 5 in the product given the exponent of 2, and the number 4 also given the exponent of 2. So 4 times 5 squared can be rewritten as 5 squared times 4 squared. And if we think about it, if we didn't reallocate the exponents of 2 and we just followed bedmass, 5 times 4 is 20, and 20 squared is 400. Everyone agree with that? If we didn't use exponent laws, that's what would end up. But within that product, if we thought of it as, instead of 5 times 4 squared, 5 squared times 4 squared, 5 squared is 25, 4 squared is 16. Does anyone want to guess what 25 times 16 is? Yes, it is. It is 400. So when you're dealing with the product of numbers, and it works with more than one number too. If you had 5 times 4 times 3 squared, you could still allocate that exponent to each of the parts of that product too. But let's look why it doesn't work with 5 plus 4. The sum does not work. The sum of two numbers doesn't work. Because if I solved it with bedmass, this would be 9 squared, which is 81. Agreed? And if I tried allocating it to this, I would have 5 squared plus 4 squared, which is 25 plus 16, which is 41, right? So the sum of two numbers in brackets put to an exponent does not work with that law. You can't reallocate the exponents to the parts of the sum, but you can with the product, okay? And that's what Law 4 states. So if I was to give you this question here, and I said, what is 3 times 8 squared? Or let's use, instead of using an exponent of 2, let's use an exponent of 3, right? If I solved it with bedmass, I would have 24 cubed, right? And I would go, well, what's 24 to the exponent of 3? The answer is 13,824, right? If I used it using the sign or the law of 4, I could reallocate that 3 to both parts of my product, and I'd get 3 cubed times 8 cubed. Does anyone know off the top of the head what 3 cubed is? Anybody? 27, good. Now, does anyone know what 8 cubed is? 8 times 8 is 64. 64 times 8, is that 512? Anybody? 512? 512. Now, there's only a couple people in this room that know what 27 times 512 is. Does anyone want to guess? Oh, come on, it's easy. Gavin, what's 27 times 512? 13,824. Gavin, you're a freaking genius. 27 times 512 equals 13,824.